Hello guys, this is Saurav here and welcome to online Pathshala Vedantu initiative to make education affordable and the outreach to be to everybody across the country. Our initiative is to make high quality content accessible to each and every student, whether they are able to attend any coaching institute or not. सभी को अच्छा सा content मिले. Okay, so this session was planned for Monday, but I'm very sorry guys that I was not well and I had to defer it to today. This is lecture 4 in the series of the other topics that we are currently doing. Lecture 4 for liquid solutions, and in this series or in this video we would be doing relative lowering of vapor pressure. Okay, relative lowering of vapor pressure. Now until now we have done 3 important aspects. हमने एक cover कर लिया है concentration. We have covered concentration terms cover किया हमने. We have covered vapor pressure. What is vapor pressure? What are the factors which affect vapor pressure? And we have covered Raoult's law and ideal solutions, जो कि हमने पिछले क्लास में cover किया था. Today's session is about the next topic and the first colligative property. The first colligative property. ये हम लोग आज बात करेंगे कि what is colligative property and what is this relative lowering of vapor pressure. So a warm welcome to everybody who is joining us today. So विशाल सिंह, ऑर्गेनिक का बेसिक से पढ़े, पहले फिजिकल तो पढ़ ले यार, ऑर्गेनिक बाद में डील कर लेंगे, ठीक है? पहले फिजिकल देख लो, ठीक है? चलिए. Okay, so what is relative lowering? This should not be Raoult's lowering of vapor pressure. This should be relative. Okay, this should be relative. I'm very sorry. This should be relative lowering of vapor pressure. Should not be Raoult's. There should be relative lowering of vapor pressure. Relative lowering of vapor pressure एक colligative property है. Now what is the meaning of a colligative property? Colligative properties are those properties which depend on the amount of substance present in a solution. Amount of substance. They are independent of the nature of substance. They are independent of the nature of substance. They are dependent on the amount of substance. For example, I take a container which contains 1 liter water. Okay, which contains 1 liter water. I take another container जिसमें कि 1 liter water है. In one container I add 1 mole of NaCl. In another container I add 1 mole of KCl. Two different salts, different cations, but the behavior in terms of colligative properties, as in osmotic pressure, relative lowering of vapor pressure, elevation in boiling point, depression freezing point, will be exactly alike. Substance के chemical nature पे depend नहीं करता है. Substance किस तरह का है, the amount of substance, it depends completely on that. The relative lowering of vapor pressure or any colligative property depends only on that. Okay, so let's talk about what is relative lowering of vapor pressure. So suppose I take a container and there are a lot of solvent molecules. These solvent molecules are evaporating, condensing, and at the point where there is an equilibrium, we would get something known as vapor pressure for the vapors which are collected over the surface of the liquid. Okay? But in a scenario where we have some solute particles, these solute particles would not evaporate, and if these solute particles do not evaporate, what we would observe is the amount of solvent molecules present on the surface decreases, and so the vapor pressure decreases. जितने solvent molecules पहले थे, let's say 100 solvent molecules पहले थे, now if there are some solute molecules also present, and these solute molecules cannot evaporate. If that is what happens, then the vapor pressure will decrease. Okay, so this is known as relative lowering of vapor pressure. We do not call it Raoult's law. We call it relative lowering of vapor pressure. Now, relative is with respect to something. Relative matlab with respect to something. Okay? So, with respect to something. So, relative is with respect to the pure solvent. It is with respect to the pure solvent. Kartavya Singh, it is important that you focus on this session right now. कोई भी और डाउट्स हैं वो बाद में हम डिस्कस कर लेंगे. क्लास खत्म हो जाने दीजिए, उसके बाद में डिस्कस कर लेंगे. ओके? ऑर्गेनिक आपके स्कूल में चल रहा है. आई एम नॉट गोइंग फॉलो और वी आर नॉट फॉलोइंग एग्जैक्टली योर स्कूल सिलेबस. ठीक है? दैट इज दिस यू शुड remember. Okay, so let's understand it in terms of the mathematical form. We had learned earlier that the total pressure of the solution, total pressure, vapor pressure of the solution will be equal to mole fraction of solvent A times P naught A plus mole fraction of solvent B times P naught B. This was taught to you earlier. Okay, this was taught to you earlier. ये लास्ट क्लास में हमने पढ़ा है. Now, ये अगर हमने लास्ट क्लास में पढ़ा है और इसमें हमने एक चीज देख लिया था कि if the solute is present, then solute का कोई vapor pressure होगा. Tell me something. If solute is non-volatile, non-volatile का मतलब उसके vapors नहीं मिल रहे हैं. So, would it have any vapor pressure? Would it have any vapor pressure? Can you please tell me in the comment section? Will solute be having any vapor pressure? No. Okay, solute would not be having any vapor pressure. So if I assume that A is a solvent and B is a solute, if I assume A is a solvent and B is a solute, then A will have a vapor pressure, but B would not be having any vapor pressure. So P naught B would be equal to 0. Okay, P naught B would be equal to 0. आर्क ज्योति चैटर्जी, यार चल क्या रहा है? Okay, what is going on? We are discussing relative lowering of vapor pressure. You are talking about osmotic pressure. That's the end of colligative property. We'll discuss that, but at a later stage. So, what is Raoult's law? What is Raoult's law? Total pressure is equal to P naught A chi A P naught B chi B, and this is equal to 0. ये 0 के बराबर हो गया. If this is also equal to 0, then total pressure can be written as equal to this. हम ये लिख सकते हैं. We can write it like this. Now, it is very important to appreciate. It is very important to appreciate कि I can write PT as equal to P naught A 1 minus chi B. Okay, I can write it like this. Total pressure is nothing but vapor pressure of the solvent 1 minus chi B, which is the vapor pressure, which is the mole fraction for the solute, which is the mole fraction for the solute. So, what do we get in return? We obtain this. We obtain this. Total pressure is P naught A 1 minus chi B, and we can simplify this. This will turn out to be P total pressure is equal to P naught A minus chi B P naught A. So if I subtract P naught A minus PT by P naught A, that will be equal to chi B. Okay, so this is, what is this? जो numerator है, the numerator is lowering of vapor pressure. Lowering of vapor pressure. Since you are dividing with respect to the vapor pressure of pure solvent, you call this whole thing relative lowering. This whole thing become relative lowering. So lowering with respect to pure solvent. Lowering with respect to pure solvent. Sneha has asked, sir, will the vapor pressure decrease if we add a volatile solute? See, I really don't know. If the volatile solute produces enough amount of vapors to compensate for whatever is the loss of solvent molecules, then the vapor pressure would not change. Okay, the vapor pressure would not change. But if it produces less amount of vapors, then obviously it might change. Okay, so the thermodynamic explanation of relative lowering is that when you mix, when vaporization takes place, it happens because of an entropy difference. Okay, it happens because of an entropy difference. Now when you add some solute, तो आपने solution का entropy increase कर देते हैं, the difference decreases, so vaporization tendency decreases. That is the thermodynamic explanation. We generally don't use the thermodynamic explanation because concept driven है, entropy वगैरह ये सारी चीजें आ जा रही हैं. So our equation will be this. Our equation will be this, that mole fraction of solute is equal to vapor pressure of solvent minus that of solution divided by vapor pressure of pure solvent. Okay, clear? So let's move forward. If suppose I want to expand this, how can I write the, sorry, just a moment. Yeah, okay, if I want to expand this, how can I write, if I know that this is equal to mole fraction of the solute. Mole fraction of solute is nothing but number of moles of solute by number of moles of solute plus number of moles of solvent. ठीक है? Number of moles of solute by number of moles of solute plus number of moles of solvent. Suppose you take a very dilute solution. You take a very dilute solution. What is the meaning of a dilute solution? Where the amount of solute is very small as compared to the amount of solvent. So if for a dilute solution, can I say that number of moles of solute plus number of moles of solvent is nearly equal to number of moles of solvent? Okay, so I cannot teach in Hindi because there are a lot of non-Hindi students over here. Okay, Artya Jyoti, the relative lowering of vapor pressure of an ideal solution containing non-volatile equal to the mole fraction solute. Yeah, you're giving the same definition. Okay, you're giving the same definition. So the number of moles of solute plus number of moles of solvent, the sum of that will be almost equal to the number of moles of solvent for a dilute solution. Okay, for a dilute solution. So with this thing in mind, let's try to solve certain questions. We start with something that we had done in the last class. एक थोड़ा सा revision भी हो जाएगा. In last class we had talked about ideal solutions, and for ideal solutions you were supposed to use this relation: total pressure is equal to mole fraction of solute A, mole fraction of solute B times vapor pressure of solute B, solvent B. Okay. This was the equation that we had used for. Vapor pressure for a solution. What is the answer to this question? Can you solve? Please try to solve the question. The question is, the benzene and toluene form nearly ideal solutions. At 20 degrees Celsius, the vapor pressure of benzene is 75 and that of toluene is 22. The partial pressure of benzene at 20 degrees Celsius containing 78 gram of benzene and 46 gram of toluene is 46 gram of toluene is The right answer is, yep, the right answer is A. The right answer is 50. How do we solve the question? Very easy. Partial pressure of benzene will be equal to mole fraction of benzene times P naught of benzene. Okay, P naught of benzene is given as how much? 75. Amount of benzene कितना दिया गया है? 78. तो 78, what is the molecular weight of benzene? What is the molecular weight of benzene? 78 is also the molecular weight of benzene. C6H6 है. 72 plus 7, 78. ठीक है? And 78 by 78 plus 46 by toluenes is C7H8. So 12784 plus 892. You will solve this. This will be 1, this will be 1, this will be 0.5. So 1 by 1.5, you will get the right answer as 50. The right answer should be 50. Clear? Chaliye. Next question. Okay. Okay. Next question. The relative lowering of vapor pressure is equal to the ratio between the number of. Please read the options and tell me what would be the right answer. Please read the options and please tell me what will be the right answer. The relative lowering of vapor pressure is equal to the ratio between the number of solute molecules and solvent molecules, solute molecules and total number of molecules, solvent molecules and total number of molecules, solvent molecules and the total number of ions in the solution. What should be the right answer to this question? What should be the right answer to this question? A lot of people have given the right answer. The right answer to this question is B. The right answer to this question is B option, because I know that relative lowering P naught minus total pressure by P naught is equal to mole fraction of solute. Mole fraction of solute means number of moles of solute by N total. So total number of solute molecules and the total number of molecules present in the solution. It's the ratio of these two, which is nothing but the mole fraction of solute. Okay, it will be equal to the mole fraction of solute. Okay, clear? Let's move on to the next question. Next question is this: the vapor pressure of benzene at a certain temperature is 640 mm of Hg. A non-volatile solute weighing 2 grams is added to 39 grams of benzene. The vapor pressure of the solution is 600 mm of Hg. How do we solve this question? How do we solve this question? It's given that vapor pressure of benzene. So benzene हो गया आपका solvent. This becomes your solvent. If this is your solvent, then P naught becomes equal to 640, and you see that total pressure after adding solute becomes equal to 600. Okay, becomes equal to 600. If it is becoming equal to 600, what you have to calculate? Molecular weight of solid. It is very easy. I will use this formula: P naught minus Pt by P naught is equal to mole fraction of solute. I have to use this formula. If I'm using this formula, then P naught is 640 minus 600 upon 640. That will be equal to mole fraction of solute. क्या लिखेंगे? 2 upon the molecular weight by 2 upon the molecular weight plus 39 upon 78. 39 upon 78. What is the answer that you are getting? What is the answer that you are getting? Please calculate. Gopal Sharma, we will not prepare you for board examination. Okay, that's not the objective. We are preparing you for mains, we are preparing you for advanced, but we are not preparing you for boards examination. Boards के लिए ख्याल आपको खुद से रखना पड़ेगा. We may have some sessions on boards, but लेकिन नहीं. Okay. So the right answer is, what are you getting as the right answer? I don't have a calculator, or I'm not calculating this. कितना आंसर आ रहा है आप लोगों का? 64 is correct. चलिए, 64 is correct. आदित्य झा, you are getting 60. 60 तो कहीं ऑप्शन ही नहीं है. Okay, the right answer should be 64. If 64 सबका आ रहा है, चलिए 64 ही right answer है. Next question. Okay, next question is, which solution will show the maximum vapor pressure at 300 Kelvin? Which solution will show the maximum vapor pressure? देखो, maximum vapor pressure पूछा है, इसका मतलब lowering is minimum or maximum. Try and understand. Question is asking, this is how they confuse you in the examination. Question is asking, they're asking about maximum vapor pressure. It means, what does this mean? Is lowering maximum or minimum? Is lowering maximum or minimum? बताइए, maximum vapor pressure तब होगा जब lowering क्या होगा? Minimum होगा. When lowering is minimum. When would lowering be minimum? When would lowering be minimum? Okay? When would lowering be minimum? Lowering would be minimum only when the amount of solute is less. Okay? Amount of solute is less. Minimum when amount of solute is less. So I have to calculate that in which case the amount of solute is least. I have to calculate the amount of solute. So what we can see is 100 molar solution. 100 molar. 100 molar means 100 moles in 1 liter water. In 1 liter solvent. Okay. 10, 100, 10, 1. This is 0.1. So minimum depression, minimum lowering of vapor pressure will be for this one. So this will have the maximum. This will have the maximum vapor pressure. Okay? Is it understood? कर्तव्य सिंह, अगर फिजिक्स वाला ने करा दिया है तो फिजिक्स वाले पे चैनल पे जाइए, यहाँ पे आके दूसरे को पढ़ने दीजिए. ओके, नेक्स्ट क्वेश्चन. The vapor pressure of pure liquid solvent is 0.8. When non-volatile substance B is added to the solvent, its vapor pressure drops down to 0.6. What is the mole fraction of component B in the solvent? What is the mole fraction of component B in the solvent? Okay, very easy. Bataiye, what will be the answer? I have not given you the options. What will be the answer? Nimisha, 0.25. Let's see. So P naught is 0.8. P total is 0.6. So P naught minus P total by P naught is equal to mole fraction of solute. Okay, mole fraction of solute. This will be 0.2, 0.8. So this will be 0.25. 0.25. Okay, very easy questions come from relative lowering of vapor pressure. बहुत easy questions आते हैं. You do not need to worry about them a lot. Next question. No, you are not late, but we are almost towards the end of whatever we are discussing. Okay. So next question is, vapor pressure of pure water is 23.8 mm of Hg. 50 gram of urea is dissolved in 850 grams of water. Calculate the vapor pressure of water for this solution and its relative lowering. Okay, relative lowering. Please try to calculate. कोशिश कीजिए कैलकुलेट करने का. कैसे कैलकुलेट करेंगे हम? What is given is that the amount of solute, so weight of urea NH2 CO NH2 is 50 gram. Okay, P naught of H2O is given as 23.8 mm. Weight of water is given as 850 gram. Okay, 850 gram. What you have to calculate is calculate the vapor pressure of water for this solution. तो vapor pressure क्या होगा? So P of H2O for the solution will be equal to mole fraction of H2O times P naught of H2O. Okay, कितना मोल फ्रैक्शन आप निकालोगे? Please calculate. The molecular weight for urea is 60. Okay, and the molecular weight for water is 18. So you will calculate this as 50 upon 60 by 50 upon 60, 850 upon 18 times 23.8. 23.8. Okay. What would be yeah, it is 50 upon 60. 50 upon 60 plus 850 upon 18. What is the problem इसमें? अरे sorry. I'm sorry. This will be 850 upon 18. I'm sorry. Mole fraction of solute निकालना है, mole fraction of solvent निकालना है. So 850 upon 18 would be there. I was calculating mole fraction of solute. So pardon me for that. So 850 upon 18 by 50 by 60 plus what is this answer coming as equal to? ये आपका आ जाएगा vapor pressure of solution. This will come as to be equal to vapor pressure of solution. 1186. How can it be 1186? It has to be lesser than, ये तो 23.8 से कम होगा ना. This value is smaller, this value is larger. We'll get to that your mind later stage. Okay, so this will give you the P, and lowering will be equal to 23.8 minus whatever you calculate over here. This will be the lowering of vapor pressure. Okay, you are getting 23.38. Okay, so 23.8 minus 23.38, that will give you the answer. Okay, 20 fine. So that should give you the answer. Clear? So this is a very, very easy concept. This is a very, very easy concept. Relative lowering of vapor pressure पे जितने questions आप हैं आप solve कर जाइए. Very easy concept. जितने भी questions आपको मिले आप solve कर जाइए. Now, when we add a solute to a solvent, what will happen is the vapor pressure is decreasing. But what will happen to the solvent's boiling point? Can you tell me what will happen to the solvent's boiling point? Now boiling point के बारे में हम next class में discuss करेंगे. Boiling point is the temperature at which the vapor pressure of the solution becomes equal to the external atmospheric pressure. हम मान के चलते हैं कि external atmospheric pressure is equal to 1 atmosphere. So when the vapor pressure becomes equal to 1 atmosphere, that will be the temperature at which it becomes equal to 1 atmosphere. It will be द बॉइलिंग पॉइंट ऑफ द सोल्यूशन। ओके, सो एक सॉल्वेंट में आपने सोल्यूट डाला, वेपर प्रेशर कम हो गया, तो बॉइलिंग पॉइंट क्या होगा, इंक्रीज कर जाएगा। ओके, इस पे डिस्कशन हम लोग नेक्स्ट क्लास में करेंगे। आज की क्लास के लिए बस इतना ही। प्लीज डू सॉल्व एज मेनी क्वेश्चंस एज पॉसिबल ऑन रिलेटिव लोअरिंग ऑफ वेपर प्रेशर। इजी कंसेप्ट है, सॉल्व कर जाओ जितने क्वेश्चन मिल जाएं। नेक्स्ट क्लास में हम लोग बॉइलिंग पॉइंट एलिवेशन पे बात करेंगे। ओके, वी विल टॉक अबाउट एलिवेशन इन बॉइलिंग पॉइंट। Okay, so this is Saurav Goswami signing off, and please let your friends know that we are conducting these classes. Take help from these classes as much as possible, and all the very best. Chaliye, bye bye.